REST API testing is one of the most in-demand and most underdeveloped skills among QA engineers right now. Almost every modern application is built on a layered architecture where the frontend communicates with a backend API, and the API layer is where the business logic actually lives. It is also the layer where bugs are cheapest to catch and most expensive to miss. A bug caught at the API level takes minutes to reproduce and document. The same bug caught at the UI level requires a full browser session, multiple clicks, and a long reproduction path before you can even confirm the behavior. And a bug that makes it to production through both layers costs your team an incident response, customer trust, and reputation. Most QA teams are desperate for engineers who can write proper API tests, and most candidates cannot do it or do not have it in their portfolio. The good news is that with pytest and the Python requests library, you can write professional, production-quality API tests without any complex setup and without a dedicated API testing tool. In this episode, we are building an end-to-end API test suite from scratch, step by step. We will test a real publicly available API, cover the full request and response cycle, write assertions that catch real bugs rather than just checking that the server responded, and set up a clean, scalable structure that can grow beyond a single file. By the end of this episode, you will have a complete, working API test suite you can add directly to your portfolio today. We are going to test the Wreckers API, which is a free, hosted, fake REST API built specifically for testing and prototyping. It has endpoints for user management, authentication, and resources, which gives us enough coverage to build a meaningful suite. The first thing to build is a base API client. Create a file called API_client.py inside your utils folder. Inside it, create a class called APIClient. The init method takes a base URL as a parameter and creates a requests.session object. The session is important because it handles connection pooling, and you can set default headers on it once rather than on every individual request. Add 4 methods to the class: get, post, put, and delete. Each method takes an endpoint string and optional keyword arguments, constructs the full URL by joining the base URL and the endpoint, calls the appropriate method on the session, and returns the raw response object. This wrapper exists for 3 reasons. First, your tests never hardcode the base URL directly, so changing environments is a one-line change. Second, you can add authentication headers, retry logic, or logging to the client in one place without touching any test. Third, it makes your test code cleaner and more readable, because the test expresses what it is doing rather than how HTTP requests are made. Now let us write the first real test. We are going to get the list of users from the Wreckers API and verify the response is correct. Create a test file called test_users.py in your tests folder. The test function should do 4 things. First, create an APIClient instance pointed at the Wreckers base URL, which is records.in/API. Second, call the getUsers endpoint with a page query parameter. Third, assert that the status code is 200. Fourth, and most importantly, assert the shape and content of the response body. Do not stop at the status code. Assert that the response JSON has a data key. Assert that the value of data is a list. Assert that the list is not empty. And assert that each object in the list has at minimum an ID field, an email field, and a first_name field. That final assertion is the one that catches the class of bug that status code checks will never find. If the backend team refactors the user model and renames first_name to give an _name, the status code is still 200. The response still comes back. But the frontend breaks because it is looking for a field that no longer exists under that name. Your test catches that immediately. That is the value of testing the response shape, not just the status code. Authentication testing is where most API test suites have the largest gaps, and filling those gaps is one of the most visible ways to demonstrate mature testing thinking. For authentication, you need to write at minimum 3 tests that together verify the full authentication contract. The first test, post valid credentials to the login endpoint and assert that a token is returned. Check that the status code is 200, the response has a token key, and the token value is a non-empty string. The second test, post invalid credentials and assert that the response is 400 and that the body contains an error key with an appropriate message. This test is often missing from junior portfolios because people test success paths but forget failure paths. Failure path testing is where the most interesting bugs live. The third test, take the token from the first test and make a request to an authenticated endpoint. Assert that the authenticated request succeeds with a 200. Then make the same request with a malformed or expired token and assert that the server returns 401 or 403. These three tests together verify the full authentication flow, happy path, error case, and authorized usage. Store the token in a pytest fixture so any test that needs authentication can request it as a dependency rather than logging in again from scratch inside the test body. That is how professional API test suites handle authentication. Schema validation is a technique that most QA engineers skip and then encounter the consequences of later. The problem it solves is this: APIs can change in ways that break consumers without changing the status code. A field can be renamed. A field can change from a string to an integer. A required field can become nullable. A nested object can be restructured. All of these changes leave the status code at 200 and break the client silently. Schema validation catches all of them automatically. Install the JSonschema library using pip. Define the expected shape of your API responses as Python dictionaries using JSonschema syntax. A user schema might specify that the object must have an ID property of type integer, an email property of type string and format email, and a first underscore name and last underscore name each of type string, with all four being required. Then write a helper function in your utils folder that takes a response body and a schema dictionary and calls jsonschema.validate. Call this validator in your tests after every response. Now if any backend change breaks the contract, your tests catch it on the next run, before any frontend code ever tries to consume the changed response. Schema validation is not expensive to write. It is a one-time setup that pays dividends every time the API is touched. Let me walk you through what a complete, portfolio-ready API test suite structure looks like. At the root you have the contest.py with two fixtures, a base underscore URL fixture that reads from an environment variable, and an API underscore client fixture that creates and returns an API client instance using the base URL fixture. Inside the utils folder you have API underscore client.py with the API client class we built, and validators.py with the schema validation helper. Inside the tests folder you have test underscore users.py covering get, post, put, and delete user operations. Test underscore auth.py covering login success, login failure, authorized access, and unauthorized access. And test underscore resources.py covering the resource endpoints. Each test file is organized with one test function per behavior, descriptively named. And at the root level you have a GitHub Actions workflow that runs the full suite on every push to main. That is a complete, professional API test project. In the next episode we are going to containerize this entire suite with Docker so it runs identically on your laptop, on a teammate's laptop, and in any CI environment in the world. Subscribe and I will see you there.